7.6 Inverse Trigonometric Ratios deals with how to find angles of a right triangle if you know a couple of sides. So first off, what is an inverse operation? Well, it's an operation that undoes another operation, like multiply undoes divide, addition undoes subtraction, and tangent undoes inverse tangent. Here are some ways that we write the inverse for sine, cosine, and tangent. In order to use an inverse function, two sides need to be given. Example 1. Use the sides of the triangle in your calculator to find the value of angle A. Round to the nearest tenth of a degree. Okay, so on angle A, the 20 is the opposite leg and 25 is the adjacent leg. So we know SOHCAHTOA. We know the opposite leg and the adjacent leg that we should use tangent. So we use the trig function for tangent, and I'm looking for angle A, and I know the other two sides. So if I undo tangent by taking the inverse tangent of both sides, I use my calculator and make sure I use inverse. In this case, it's A tan, or arctangent. I plug it into my calculator and I get 38.7 degrees. That is the angle from the two sides that were given. Example 3, solve the right triangle. That means find all three sides and three angles. So I'm going to write what I know. I know 2 out of the 3 sides and 1 out of the 3 angles. I can find side AB by using the Pythagorean theorem, since I know 2 out of the 3 sides of a right triangle. So I make my substitutions and solve for side AB, and I can use my calculator, and it ends up being a perfect square, 18. So side AB is 18. Now I know all 3 sides. I can find the measure of angle B by using the inverse sign, because I know the opposite side and the hypotenuse. So sine of B equals the opposite leg over hypotenuse. Sine of B equals 24 over 30. And if I take the inverse sine of both sides, or the inverse sine of 4/5, make sure you include 4/5 inside the function in the parentheses, and I get 53.13 degrees, or 53.1. So I'm going to label that. Now I could use the triangle sum theorem and find the third side, or the third angle, but I think I'll use the inverse cosine just to practice using this, because I know the adjacent and the hypotenuse, and these are also given sides, so they're exact values, whereas the angle B that I found is rounded, so this is going to be a little more exact. So I get 36.9. All angles add up to be 180. Next example, example 4. Same thing, I need to find all 3 sides and 3 angles. In this case, I know an angle in I know 2 angles in one side, so I can find AB using sine. This time we're going to use regular sine because I'm looking for a side. If I were looking for an angle, I would use the inverse sine. So I'm going to solve for AB, 25 divided by sine of 62. We're using regular sine here, not the inverse sine. And I get 28.31. So side of AB is 28.31. Put that in my chart. Now I'm going to find BC by using tangent, because I know the opposite leg, and BC is the adjacent leg of 62. So we're familiar with this. We've done this in the last section. Plug it in my calculator. I'm looking for a side, so I use tangent, and I get 13.29. So BC equals 13.29. Put that in my drawing. And then lastly, we can find angle A by using the triangle sum theorem. Angle A plus angle B plus angle C equals 180. So I make my substitutions for 62 and 90, and I get angle A is 28 degrees. And that's it. Example 6. A 25-foot tall flagpole casts a shadow of 42 feet. What is the angle the sun hits the flagpole? Well, in this case, I know the opposite leg is 42, the adjacent leg is 25. I can put it in my tangent equation, and I'm looking for x, which is an angle, so I need to use arctangent 42 over 25, and I get 59.2 degrees is the angle. That's a pretty easy equation, pretty easy problem. Okay, lastly, example 7. Lisa is standing on top of a 50-foot building and spots her friend Molly across the street. Molly's 35 feet away. The drawing shows 30. The problem says 35, so I'm just going to fix that for 35. And Elisa's height is 4.5 feet. So I'm going to use inverse tangent again. So the total height at eye level would be her height plus the building, which is 54.5, and Molly's 35 feet away from the base, so I use the inverse tangent of 54.5 over 35, and I get 57.3 degrees. And that's my angle of depression. And that's it. We're done.